All right, hey guys, Trig day number 7, part 2. This is the last video lesson for this chapter. So without further ado, let's get into some law of sines, cosines, and area of a triangle. Okay, so law of sines, I'm not going over the proof of this in this video. I can do another video and post it for you. But A over sine A is equal to B over sine B is equal to C over sine C, where all the lowercase letters are side lengths of the triangle and uppercase letters are the angles of the triangle. And of course the angle is across from said side. So for both law of sines and law of cosines, angle A would be across from side A, angle B across from side B, angle C across from side C. That would apply actually to all three of these. And so when we work with law of sines, potentially we could be finding either a side or an angle. So we need to have inverse sine skills as well as just cross multiplication. Law of cosines, I've got two different formulas. The first one is typically used to find a side C. It can be also used to find an angle C, but you'll end up working with this equation here once you're finding an angle, as well as the area of a triangle, where if I have two sides and the angle in between it, I can find the area of the triangle. That proof's real simple. I could do it in another video. It's pretty cool. All right, so let's get started with an example. And sometimes it can be hard to determine, should I use law of sines or law of cosines or the area of a triangle? Well, it's pretty easy to typically be able to figure out whether or not you're trying to find the area because it'll somehow reference area. So in this case, area function or formula is out. We're going to use either law of sines or cosines. Now, when you first start toying with problems like this, you'll maybe go down a rabbit trail and then you realize, oh my goodness, maybe I should have used the other formula. So in this case, what we're going to do is we are going to use the law of cosines. Okay, I'm going to use the law of cosines in order to solve for x. All right, so let's go ahead and do that. Now, the only angle I'm given is angle A, and I'm actually going to rename that just for the moment. I'm going to rename that C. Right, because then this would become side C. So when I do my work with this, you'll see what I mean in a second here, but I would take C squared, which is 2x minus 1 quantity squared, set it equal to A squared plus B squared, so I'll call A, I really don't care, let's call it x, plus B squared is 5 squared minus 2 times A times B, and notice, like, I don't really even care what letters you use, provided that this happens. This angle is the angle across from that side. That's all that matters. Okay, so let's see if we can solve for x, because now we have everything in terms of just x. All right, so that left side would be 4x squared minus 4x plus 1. The right side would be x squared plus 25 minus, this would be 10x cosine, how about the cosine of 60? Well, the cosine of 60 is a half. So what I'm getting is 4x squared minus 4x plus 1 is equal to x squared plus 25 minus 5x. All right, let's get everything to one side. So that would make 3x squared on the left. That would make 1x. And that would make a minus 24. Oops, not 25, 24. All right, so I'm going to get two possible values for x here, potentially. I'm going to factor. Let's factor by going 3x minus 8 and an x plus a 3. All right, that would yield for us an x value of 8/3 or an x value of negative 3. Now, x equal to negative 3, since the side length makes no sense here. Therefore, x must equal 8/3. Okay, so now what I've got here is 8/3 for the side length AC, and then 8/3 minus 1. And I'm going to scratch these because I just used them for formulaic purposes. So I'm going to multiply that by 2, which would be 16/3 minus 3/3, that would make this side 13/3. Okay, so what I'm looking for is calculating the measure of angle ABC. Okay, so ABC will be this angle, right? Notice the hat over the B, that means angle B. And angle ACB, which will be this angle right here. Okay, so let's start with the blue angle. Okay, so we're going to take 13/3. Now we're going to use the law of sines, you guys. So the law of cosines got us x. Let's use the law of sines to get us the angles. Actually, we're only going to have to use the law of sines once, and you'll see why in just a second. Okay, so this 13/3 over sine of 60 should equal, we want B, so 8/3 over the sine of B. Okay, now at this point, you guys might be comfortable with this, maybe not, but algebraically I can drop those 3's. So cross multiplying, I'd get 8 sine of 60 is equal to 13 sine of angle B. All right, I'm going to divide both sides by 13. That yields for me the sine of angle B is equal to that expression. And this would be a calculator allowed question, I would assume, seeing that these numbers are not going to be pretty. The inverse sine of this thing, utilizing my calculator and going to 3 sig figs, the measure of angle A, BC would equal, comes out to be 32.2 degrees. Okay, so I got measure of ABC, and I have the measure of BAC, right? So the 3 angles themselves have to add to 180. Therefore, the measure of angle ACB will equal 180 degrees minus 60 plus 32.2. All right, so the measure of angle ACB comes out to equal 87.8 degrees. Okay, now one thing to be aware of is that sometimes images are not quite to scale, so don't let that hurt your feelings. Trust the math, but also make some logical steps along the way. All right, let's look at another example. Okay, measure number 2, find the measure of the smallest angle. Okay, the smallest angle will always be across from the smallest side. All right, so this would be the smallest angle, angle X. Okay, so I can't use law of sines here because in order to use law of sines, I have to have some kind of side angle pair. All right, so I've got to have an angle given in order to find another missing part. So what I'm going to do here is I'm going to use the law of cosines. And what I'm going to do is make sure that the side over here matches the angle over here. Right? So we spoke about that earlier. Make sure that those pair up nicely. Okay. Now from there, I'm going to take 5 and 6 and call them A and B, what we've seen in the formula. So 5 squared plus 6 squared minus 2 times 5 times 6 times the cosine of x. Now we're going to solve for x. We're going to have to do an inverse at the very end to find an angle. That's okay, we can do that. So that's 4 is equal to 25 plus 36, which is 61, minus 2 times 5 times 6, which is 60, cosine of x. Now this is actually a very simple problem. So we're going to get negative 57 over negative 60. So I subtracted 61 divided by negative 60. That equals cosine of x. So to clean that up just a tad, we got negative 57 over 60 equal to cosine of x. Therefore, x is equal to the inverse cosine of 57/60. You could reduce that if you wanted to, but it doesn't really matter. It might be type A and really want that, but whatever. So angle X is 18.2 degrees. Let me write that in proper notation. So the measure of angle ZXY, you could write YZX if you wanted to, or YXZ. But this would be a proper notation for the smallest angle in that triangle. All right, outstanding. Let's move on to number 3. We want to find MA, MB, and MC. Assuming that MA, or the measure of angle BAM, is pi over 2, which is 90 degrees. Okay, so we're given that. That brings all right triangle trig to our doorstep. We're going to call this length from A to B X, and this length from here to here was 15, just to clean up some potential confusion there. All right, so I want to find MA, I want to find MB, I want to find MC. So the first thing I'm going to do is I'm going to write expressions involving MA. So the tangent of 23 is equal to MA over x plus 15. Okay, likewise, the tangent of 64 is equal to MA over x. Okay, so what you might see that I'm already going to do is I'm going to solve for MA, which will allow me to solve for x. Okay, so let's do that. I'm going to solve for MA in the first expression, so MA will equal, I'm going to multiply both sides by x plus 15, so that'll be x tan 23 plus 15 tan 23. Okay, I distributed tan 23 to both x and 15 there, kind of skipping some steps along the way. MA is also equal to x tan 64. Now what I can do at this point is set these two equivalent. So x tangent 23 plus 15 tangent 23 is equal to x tangent 64. Let's isolate x all by itself. That would involve subtracting x tan 64 to one side, potentially. I'm going to actually go the other way, and I'm going to subtract x tan 23. So if I took x, and I'm going to factor out the x at the same time. So all I did was subtract x tan 23 to the right, and then I factored out an x. Now what x will equal then is going to be 15 tangent 23 over tangent 64 minus tangent 23. All right, now when I use my calculator, I'm going to get a value of about, to 3 sig figs, 3.92 meters. Okay, I get 3.92 meters. So as you look at the diagram, clearly it's not to scale. Okay, this looks longer than 15. In reality, this is 3.92 meters. So this is a case where you don't want to trust the image, you want to trust your math. Okay, so I'm kind of putting this to the side. And what I've done is in my calculator, I have stored, there's a button called stow. I've stored x as 3.92, and I'm going to use that so I don't have issues with rounding. You never want to round and then use that number, because if you round and then use it, and then round and then use that, your error will expound itself along the way. Okay, so now let's solve for MA. Now, when I want to solve for MA, I'm going to find the easiest or simplest expression for MA. So I'm going to take MA and set it equal to this value x, right? I stored it, and I'm going to multiply that by tangent of 64. And my calculator spits out an answer of 8.03. Oops, that shouldn't say x there, that should say MA. All right, so MA is about 8.03 to 3 sig figs meters tall. Okay, if it asks for MA, you are totally fine rounding that and using sig figs. Okay, but if you decide to use it, then again, I would store this 8.03 as, you could call it Maybe don't call it M because you can use that letter a lot. Maybe call it A because it's unique to using A. All right, so then after that, what I want to do is I want to find expressions for both MB and MC. So let's set those up. So let's use cosine of 23, and the cosine of 23 would be x plus 15 over MC, and then the cosine of 64 would equal x over MB. Okay, so now I can find expressions for both MB and MC. MC would equal x plus 15 over cosine 23. This is really important now that I have x stored because I can just plug and play, right, for x. So I have stow x, I can use it right there. So when I do that, I get a value for MC of 20.5 meters. And then likewise on the other side for MB, MB is going to be equal to x over cosine of 64. It's just so convenient to be able to use that stow button so that I don't have to keep punching the numbers in. I can just recall those values. So when I recall x, it looks like MB equals 8.93 meters. Okay, guys, there you have it. That's an impressive way to use right triangle trig. I didn't use law of sines or law of cosines, but this is a good example of using right triangle trig to do said type of problems. Okay, let's move on to the next question. Okay, so question number 4 is going to require some geometry skills from us. Okay, so just so you're aware, this angle A is going to, it's called an inscribed angle. Whatever the measure of this arc is, angle Y is half of that measure. Okay, and because angle O is a central angle, whatever the measure of this arc is going to be equivalent to this. So let's call this, I don't really know. Let's call it W. So this would be W. And actually, I'm going to switch up. Instead of calling this x over 2, I'm going to call this x. I'm going to call this 2x. Okay, so I know 2 times the measure of angle Y. So 2 times the measure of angle Y plus the measure of angle O, which I'm going to call W, should equal 360 degrees. Okay? Because the arc all the way around a circle should measure 360 degrees. So let's kind of toss that to the side. Okay, and I'll do a quick erase on that. Okay, so now let's get into this. Clearly it's asking for area, so I'm going to use a formula. A equals 1/2 AB sine of C. All right, so I got to find some angles here because I got sides, right? In essence, what I'm going to do here is I'm going to split this into 2 triangles. So I've got the 2 sides of one triangle and the 2 sides of the other triangle. I'm going to add them together. So I would have, let's call it area 1, would be 1/2 5 times 5 times the sine of what I'm going to call angle W. And the second area would equal 1/2 3 times 7 times the sine of that angle measure, which I'm calling x, I suppose. Okay. All right. So let's clear this up just a little bit. This will be 25/2 sine of W. And this will be 35/2 sine of x. Okay. So, and I just noticed I used y here. Let's call it x. All right. So let's look at how we go about completing. All right, I'm going to do a little dissection here. And I'm going to go like this. Okay, this is the point X, this is the point Y, this is the point O. Okay, this will be an isosceles triangle. So I can find this angle using the law of cosines. So I would take 3 squared equals 5 squared plus 5 squared minus 2 times 5 times 5 times the cosine of the angle in between. So I'm going to call that angle O. Not cosine of 0, cosine of angle O. So that'd be 9 is equal to 50 minus 2 times 25, which would be 50 cosine of angle O. I'm going to subtract, so subtracting 50 and dividing by negative 50, I would get 41/50ths is equal to cosine of angle O. All right, so using my calculator, I do the inverse cosine of 41/50. I get 34.9. Okay, so angle O right here is 34.9 degrees. All right, now I'm going to draw the second triangle involved, where this would be Y, and this would be O, and this would be Z. So these two angles, here was the 34.9. These two angles will give me angle W, the sum of them. All right, so in this case now, when I look at this triangle, I've got a 5, I've got a 5, and I've got a 7. Okay, I got a 5, and a 7. I'm going to use law of cosines again. So 7 squared equal to 5 squared plus 5 squared minus 2 times 5 times 5 times the cosine of, let's call this angle P. I don't care. Okay, angle P. So it'd be 49. We have 50 minus 50 cosine of angle P. Okay, law of cosines is huge here. Subtracting and dividing by negative 50, I get 1/50th is equal to cosine of angle P. All right, it's going to be a pretty big angle. So the inverse cosine of 1/50th. Yeah, it's 88.9 degrees. So angle P, 88.9 degrees. I'm going to add those two numbers together. Which gives me 124 degrees. Okay, so angle W, I'm going to put it up here in purple. Let's go with purple, yeah. Angle W is the sum of those two angles, which is 124 degrees. So I'm going to utilize that right here. So the area of the first triangle will be 25 halves sine of 124 degrees. Now I'm going to utilize the number that was given, not 124 degrees, times the sine of that angle. It's going to give me 10.39. Okay, so the area here, area 1, is 10.4 centimeters squared. Okay, area 2. Notice what we had up here. 2x plus w. W is 124 degrees. It's equal to 360. All right, so when I solve for that, 2x is equal to 360 minus that stored value, not 124. So I get 2x equals 236.23 divided by 2, and I get 118. So x equals 118. So the area here is 35 halves sine of 118. So let's do that. 35 divided by 2 times sine of 118. We get 15.435. I'm going to add that 15.435. So the total area will be these two values added together. I add them, and I get to 3 sig figs, 25.8 centimeters squared. Okay, so I've kind of loaded this a little bit, but I'm storing a bunch of numbers, right? I'm estimating with 124, I'm estimating with 118, but I'm using the calculated stored value for that. Okay, let's look at one more here on this slide, and then we'll see what we got on the next. Find the area of the shaded region in the diagram. Okay, let's see what we can do here. It looks like if I could take the area of the sector and subtract out those white spaces, we would be pretty darn good. Okay, so let's do this. Let's find the area of this triangle first in terms of R. Okay, so what I need is the angle, this central angle, which is pi over 4 plus pi over 4 plus pi over 6. So that's 2 pi over 4s plus a pi over 6, which will equal, what would that be, pi over 2 plus pi over 6, which would be the same as 3 pi over 6 plus pi over 6, which is 4 pi over 6, which is equivalent to 2 pi over 3. Okay, so I got my angle. I need my radius. Well, my radius is R. This right here is equivalent to 120 degrees. So the area of the triangle that we've got highlighted over here would be R times the sine of 120. Okay, so we would have R squared over 2, and the sine of 120, I believe, is root 3 over 2. Root 3 over 2. So the area of that triangle would then be R squared root 3 over 4. Okay, in general terms. Let's find the area of this small space right here. It's called a segment. Now, a segment is a sector minus a triangle. So if I were to resketch this, that's the sector minus the triangle. So the triangle has an angle of pi over 6, which is 30 degrees, and a radius of R. Let's find the area of this red triangle, and then the area of the overall sector, and I'll go over the formula of that in just a second. So the area of the triangle will be 1/2 R, we can just go with R squared, because we know it's going to be R times R, sine of pi over 6. Okay, so that would be R squared over 2 times 1/2. So that area would be R squared over 4. Okay, the area of a sector, is the angle theta over the fraction or the ratio of the entire circle times pi R squared. Okay, so I'm going to leave this. In radian form for just a minute, and then you'll see what happens here. Okay, so A is equal to pi over 6 over 2 pi times R squared. All right, so I get, let's see, what do I get? That's, well, the pi's reduce, clearly. These pi's, well, hold on now. This would be pi over 6 times 2, which is 12 pi times pi R squared. So we're going to get a reduction here. These pi's reduce. And so the area of this blue region would be pi R squared over 12. All right, so I've got the red space, the red triangle, I've got the blue sector. I just need this green space, right, which would represent that right there. So I'm going to take the blue area, and subtract the red area, and that'll give me the green area. So pi r squared over 12 minus r squared over 4 is equal to A. Okay, so if I want the blue space, right, the blue shaded region, the original blue shaded region, I'm going to take the area of the sector and subtract those two areas. Okay, so let's just do this one in yellow. Okay, I'm going to take the area of the sector, the whole thing, which would be, let's see, the whole sector would be 2 pi over 3 over 2 pi times pi times r squared. Okay, that was the original central angle, right, like this. This angle was 2 pi over 3. Okay, and then I'm going to subtract away, once I find this and simplify it, I'm going to subtract away both the green and the yellow space. Of course, this was the yellow here. Okay, so that'll be, let's reduce a little bit here. These pi's will reduce. So this part of the expression reduces to 1/3. Yeah, that'll be 1/3, so I'll get pi r squared over 3. Okay, that's the total area. So I'm going to take that total area minus both the green area and the yellow area. All right, so the green area, let's see what we get here. So that's pi r squared over 3 minus pi r squared over 12 minus r squared over 4 plus r squared root 3 over 4. I mean, if it was okay left in this form, cool. If not, let's clean it up just a little bit. All right, so these look like terms because they got pi's involved. So let's call this 4 pi r squared over 12 minus, that would be pi r squared over 12. Now when I distribute the negative, it'll make this a plus r squared over 4 and a minus r squared root 3 over 4. All right, so I'm going to get 3 pi r squared over 12 plus r squared over 4. And actually, I'll compress this. Oops, that should be r squared root 3 over 4. So let's simplify. This would be pi r squared plus r squared minus r squared root 3. That's a 3 all over 4. That's the area of the shaded region. Wow, that was quite the job there. All right, outstanding. You could have rewritten this in a different form. We could have, I suppose, factored out an r squared and left it as pi plus 1 minus root 3 all over 4. That's a much nicer looking result. Granted, not all that satisfying because we don't know what r is, but it formulates a general function for us. Okay. We got, I think, one more slide, and then that's it for part 2. Okay, guys, we're going to solve the two triangles using the ambiguous case. Okay, so in triangle ABC, what we got is two different situations. Okay, so here's angle C, here's angle A, here's angle B. Okay, we're given that AB is 7 meters. We're given that BC is 10 meters. We're given that this angle for C is 30 degrees, but we don't know side B. All right, now the ambiguous case happens when you're given side-side angle, right? I'm given 7, 10, and 30 in that order, right? So what could happen potentially is what you get is this this isosceles triangle situation showing up where you swing one leg over to the other right there. Now what happens is that these two angles are the same, and the red and green angles add up to 180. Okay, so nothing changed here with 30 or the 10 or the 7, right? But what you get is two different A values. So here's A1 and here's A2. Okay, so there's two different ways to go about this. You could go about with the law of sines to find the angle measures A1 and A2, or you could go about it with the law of cosines. Now, with the law of cosines, that's going to help you find the sides, because it says solve the two triangles. That means find all sides, all angles. So what I'm going to do is I'm going to use law of sines with the initial triangle, this one here, and I'm going to say the sine of 30, 7 divided by that, is equal to the sine, is equal to 10 over the sine of A1. All right, and when I solve that, I cross multiply. I end up getting for A1, when I set everything up, the inverse sine of 10 sine of 30 divided by 7. A1 comes out to be 49.2 degrees. Now the cool part, like we said, so that's A1. That would be our red angle right here. Okay, A2 ends up being supplementary to that. So A2 ends up equaling 180 minus that, which I would, to 3 sig figs, say is 131. Okay, so I've almost solved the triangle because I found those two angles. All right, now I got to find the two possible values for B. So this would be B1 and this would be B2. Notice that B2 would be smaller than B1. So what I'm going to do is I'm going to set up using the law of cosines. 7 squared is equal to 10 squared plus B1 squared. Actually, I'm not going to write B1. I'm just going to write B squared minus 2 times 10 times B times the cosine of 30. Now it's going to yield for me a quadratic where I will solve for B, and there will be two values. That'll be 49, this would be 100. B squared minus, this would be 20. Well, let's see what cosine of 30 is. Cosine of 30 is root 3 over 2. So imagine that I'm multiplying 20 times that. That would be negative 10 root 3 times B. Okay, and then I'm going to get everything on the same side. So I'm going to subtract 49. So that would be B squared minus 10 root 3B plus 51. So I'm going to use the Pythagorean theorem, or not the Pythagorean theorem, the quadratic formula here to find the two values for B. So it'd be the opposite of B, well, the coefficient of the linear term. So the opposite of negative 10 root 3 plus or minus B squared, which would be 10 squared times 3, which is 300, minus 2 times A times C. So that's 2 times 1 times 51. Or excuse me, 4AC. So that would be 204. Okay, so B will equal, and of course I'm going to divide by 2A, which would be just B2. So I'd get 5 root 3 plus or minus the square root of 96 over 2. Well, 96 has a perfect square that goes into it. 4 goes into it 24 times. But so does 16, I believe. Yes, it does. It goes into it 6 times. So B would equal 5 root 3 plus or minus. So I could pull out. So here, let's do this. I'd have 16 times 6 over 2. So as I bring that 16 out, since it's a perfect square, the square root of 16 is 4, and 4 divided by 2 is 2. So B equals 5 root 3 plus or minus 2 root 6. All right, so let's solve for the two triangles in question. So here was A1, here was B, here was C. We had 30, we had 10, we had 7, oops, that was meters, I believe. Okay, B1 would be the larger of the two of those. So B1 would be 5 root 3 plus 2 root 6. Okay, and I had found A1 to equal, yeah, 49.2. Okay, so I've solved that triangle. All angles, actually I haven't, not quite yet. I gotta find angle B. Angle B is supplementary with 30 and 49.2, which would be 100.8. Actually, I'm gonna go 101 to 3 sig figs. Now the other triangle, okay, here's B2, or excuse me, A2, which I said was 131. This was 30. So that's 161. That leaves 19 degrees left for B2. Okay, nothing changed with C. Nothing changed with this side length of 10 or 7. So B2 would be the smaller of the two, 5 root 3 minus 2 root 6. Okay, guys, heck of a deal there. Law of cosines, law of sines, area of triangles, it's all good. We'll see you in chapter 2, some calculus. Let's get it going. Have a great day.